Evet, tüm katılımcılarımıza günaydınlar diliyorum. Ben doçent doktor Emine Kemiklioğlu, Manisa Celal Üniversitesi Biyomühendislik bölümünde görev yapıyorum. Bugünkü 7. oturumumuz için de hoş geldiniz. Sunumlar için konuşmacı davet etmeden önce toplam sunum süresinin 15 dakika olduğunu ve son 5 dakika kala da sizlere hatırlatmada bulunacağımı belirtmek isterim. Tüm konuşmacılarımıza başarılı bir sunum dileyerek oturumu başlatıyorum. İlk çalışma Umar Muazı Yunus'a ve Raziye Öztürk Ürek tarafından yapılmış olan HPLC Analysis and Antioxidant Activity of Phenolic Extracts from the Fruits of Mespullus germanica başlıklı sunumu yapmak üzere de konuşmacıyı davet ediyorum.
Hocam katılımcılar yok sanıyorum ilk sunum için. İkinci sunumdakiler.
Buradayım.
Burada ya
Katılımcı burada 21.
Pardon.
Evet.
Kusura bakmayın, özür dilerim.
Tamam.
Tamam. Şimdi paylaşabilirsiniz. Kusura bakmayın tekrardan.
Tamam. Good morning. My name is Umar Muaz Yunus. A master's student from the Kusali University, studying biochemistry. Today I'm going to present on the following topic: HPLC analysis and antioxidant activity of phenolic extract from the fruit of Mespullus germanica. The content of my presentation are as follows. Introduction, objective, methodology, result and discussion, conclusion. Introduction. Phenolic compounds are major phytochemical found in several plants. This phytochemical has many health benefits. They contain benzene ring with one or more hydrogen substrates attached to them. These phenolic compounds are further subdivided into this larger group of phenolic acid, flavonoid, tannin, and sterolins. Phenolic acid. Phenolic acid are aromatic compound containing phenol ring and the organic carboxylic acid group attached to carbon-6 to carbon-6 skeleton. They are the second most widely distributed flavonoid after flavonoid. They are category divided into two: those derived from hydrobenzoic acids and those derived from hydrocinamic acids. Those derived from benzoic acid are benzoic acid, vanillic acid, stearic acid, etc. While those derived from cinnamic acid are fucumaric acid, ferrolic, synapic, and caffeic acid. These phenolic acids are sourced from several plant food, including beverage and fuels. The hydrobenzoic acid are derived from strawberries, raspberries, blackberries, blackcurrant, tea, and etc. While hydrocinamic acid derivatives are derived from apples, cherries, plums, potatoes, eggplant, and etc. The phenolic acids are known to contribute health effects in doing so by scavenging free radical and thus preventing oxidative damage caused by DNA to other biomolecules such as carbohydrates, protein. The flavonoids are the widely most diverse group of plant polyphenol. They contain two or more hydroxyl rings and several phenolic hydroxyl groups attached to them. The flavonoids are usually subdivided into anthocyanidin, flavone, flavonol, flavonol, flavonol, and flavonol. These flavonoids are known to have antimicrobial properties and are known to possess potent inhibitor of certain enzymes, such as oxidase, cyclooxygenase, and lipoisogenase. These are the classification of the flavonoid that I have said earlier. The Mesophyllus germanica. Mesophyllus germanica belong to the genus of Mesophyllus and is usually found wild in northern and western Anatolia, Karadeniz, Aegean, and Marmara regions of Turkey. Several research carried out on the Mesophyllus germanica have revealed its bioactive compounds such as phenolic acid, antioxidant, organic acid. These are the fruit of Mesophyllus germanica, the fruit we use in the following research. The objective of the current study was to profile flavonoid and phenolic acid from different extracts of Mesophyllus germanica fruit and to evaluate the antioxidant potential of the extract. So the sample was collected from the nasally, air-dried, lyophilized, and ground into powder using milk grinder. Thereafter, a certain amount of the milk was extracted with solely extractor for 4 hours. The departed bread was allowed to dry and subjected to flavonoid and phenolic acid extraction. For the flavonoid extraction, 4 flavonoid group of compounds have been extracted: flavon, flavonone, flavonol, and flavon-uchol. For the flavon-uchol, we carry out 2 extraction: methanolic extraction and the acid extraction. Flavonol was extracted with the ethyl ether flavonol, with ethanol water flavonol, with acidified methanol. For the flavon-uchol methanol production, absolute methanol was used, while for the flavon-uchol acid extraction, the residue after methanolic extraction was dried and subjected to acid extraction using acidified methanol. For the phenolic acid, the departed brain after solely extraction was extracted with the methanol using magnetic stirrer. The extract was centrifuged. The pellet was re-extracted following the same procedure mentioned earlier, while the residue dry was allowed to die before subjected to experiment related to bound phenolic acid extraction. So the 2 methanolic extracts were full together and evaporated. Thereafter, the methanolic extract was further pre-dried and lyophilized. The lyophilized methanolic extract was subjected to experiment related to extractable phenolic acid. In extractable phenolic acid, we carry out 2 extractions from the lyophilized methanolic extract. The lyophilized methanolic extract was dissolved in acidified water and partitioned with the ethyl ether 3 times. And thereafter, the combined ethyl layer contained pre-phenolic acid extract. The water phase after pre-phenolic acid extraction was neutralized to natural pH with sodium hydroxide, dry and lyophilized. The solution was then acidified to pH 2 and partitioned with an ether. The resulting ether layer contained basic hydrolysis phenolic acid fraction. The water phase after the second extraction, that is after basic hydrolysis phenolic acid extraction, was treated with hydrochloric and heated at 95 degrees for 20 minutes. The solution was again partitioned with ethyl ether as mentioned above. The 3 fraction was concentrated to dryness under vacuum, pre-dried, and lyophilized. While the residue after methanolic extraction was subjected into 2 homo extraction to extract hydrolyzable phenolic acid in the brand that were not extracted by aqueous method. So the residue was carried out, the extraction was carried out using 2 protocols. The residue were divided into 2 equal parts. For protocol 1, 1 part was treated with alkaline, in which half of the residue was extracted with 2 molar sodium hydroxide for 4 hours at room temperature. The solid was centrifuged and filtered. The supernatant contained bound phenolic acid from hydrolysis. The pellets was subjected to acid hydrolysis with soda hydrochloric for 1 hour at 95 degrees Celsius. The slurry was centrifuged and filtered. The supernatant contained bound phenolic acid from hydrolysis. In protocol 2, acid hydrolysis was done first, thereafter followed by alkaline hydrolysis. And two fractions, bound phenolic acid hydrolysis 1 and bound phenolic acid hydrolysis 2 were obtained. The four fractions were partitioned with diethyl ether 3 times dry and lyophilized. For the HPLC analysis, the lyophilized sample was constituted to
excuse me, let me remember you. You have only 5 minutes left.
Okay. To 1000 ppl using methanol, and separation was accomplished using C18 reverse phase volume. The chromatograph detection was achieved with the actor. For chromatographic analysis of flavonone, mobile phase was set for formic acid and methanol. Chromatogram was recorded at 350 nanometer. Flavonone were identified by comparing the detection time with those of apigenin, lutein, diosmin. Chromatographic analysis of flavonone was carried out at 370 nanometer. For the chromatographic analysis of flavonone, the chromatogram was recorded at 285 nanometer, and the flavonone compound was identified by comparing their retention time with those of apigenin, naringenin, and hesperidin. So for chromatographic analysis of flavonone, which all the chromatogram was detected at 180 nanometer. For the phenolic acid, two mobile phase was mobile A are acetonitrile and the mobile B are 2% acetic acid in water, and the chromatogram peak were monitored simultaneously at 280 and 320 nanometer for benzoic acid and cinnamic acid derivative. And sample was eluted under the following gradients. Phenolic acids were identified by comparing the retention time with those of standards: vanillic, ferulic, synapic, capic, and etc. And Antioxidant activity determination were done using 4 different methods. This includes 2,2-diphenyl 1-picral hydroxyl free radical scavenging assay, hydroxyl radical scavenging assay, chelating activity, break reducing power, result and discussion. 3 compounds were detected, 3 flavonoid compounds were detected from 5 flavonoid extract. Hesperidin was detected from flavonone with concentration of 2.11 parts per million. Vicatechin, epigallocatechin were detected from flavonone, which all methanol fraction. Among the 3 compounds detected and identified, epigallocatechin has highest concentration of 61.26 parts per million. For the phenolic acids, 4 phenolic acid compounds were identified: protocatetic acid, ferulic, syringic, and vanillic acid. And our extract from acid hydrolysis fraction and bound phenolic acid hydrolysis fraction, bound phenolic acid hydrolysis 2 fraction, we didn't identify any of the compound because their retention time didn't correspond with those of our standards. Among the phenolic acid identified, phenolic acid had the highest concentration from the basic hydrolysis phenolic acid with 9.35 parts per million, and it also possesses the lowest concentration from bound phenolic basic hydrolysis 2 extraction. Results obtained from the current research show that the basic hydrolysis as an effective method, because most of the phenolic acid were detected from basic hydrolysis phenolic acid and the basic bound phenolic basic hydrolysis 1 and 2 fractions. The result of the current study was also similar to the work of Kim et al. In that study, vanillic, syringic, ferulic acid were detected in basic hydrolysis extract. For the antioxidant assay, the result for the metal chelating DPPH and OH radical scavenging assay was presented as follows. The lower the IGP value, the higher the antioxidant activity. Bound phenolic basic hydrolysis extract had high metal chelating activity with 448.33. DPH has bound basic hydrolysis phenol ester has high DPH and the hydroxyl radical scavenging activity. For the metal chelating assay, Methods such as
Your
iron
time
2%
your
ability
time
to
is
synthesize.
almost done.
Okay. For methylation activity, acid prokaryotic and pyrrolic acid found in this may be responsible for the high methylation activity of the two fractions. And DPPH, the result of our study is better than what we obtained by other researchers. These are the result of all this radical scavenger activity, and the high OH quenching power of bound hydrolyzed phenolic acid may be related with the strategic phenolic acid identified. The two phenolic possess hydrolyzed group in their structure, so they can scavenge hydrolyzed radical through protein donation. The result for periodic reducing power as follows: bound base hydrolyzed phenolic acid at high periodic reducing potential. In conclusion, the antioxidant power of base hydrolyzed phenolic ester was zero. It showed that high in DPH and OAG radical scavenger activity, and its ability to transform ferric to ferrous iron was zero. A significant antioxidant activity observed from the different ester from Espilia germanica could be as a result of the phenolic compound identified, such as epigallocatechin, epicatechin, ferulic, prokaryotic, syringic, and vanillic. Turkey is a research of edible plant, among which Espilia germanica. The present study compound the antioxidant activity of this plant, thus it's compounded by a chemical potential. The references are used in the research. Thank you for listening.
Thank you for your nice presentation. Is there any question?
Yes, I have a question, please. I'm sorry, but I think it has taken some time. Okay, my question, thank you for your presentation. I'd like to know, you have used for the extraction, you have used oxalate. Why did you use the oxalate? There is no any effect, any heat effect of the flavonoid compound? This is the first one. And for the flavonoid extraction, which method you have used? It's chromatography, because it was just writing like flavonoid extractions. And for the antioxidant activity, what was the control you have used to compare with your samples, please? Thank you.
Okay. For the soda extraction, we use it to remove a lipid content from the plant so that they cannot interfere with our results. And the your second question?
On the extraction, it was by chromatography. Which type of chromatography? It's HPLC or colon chromatography you have used?
It's HPLC, as I've said earlier. We did HPLC analysis for the flavonoid and phenolic acids.
Okay.
And our compound for the flavonoid, these are the compound, the standard we use for identification. In flavonoids, apigenin, lutein, and the flavonol, we use acetylene quercetin as our reference. And the last question is,
it's the control you have used for the antioxidant, for the DPPH antioxidant activity.
We use vitamin C as our control.
Excuse me, maybe it is better to ask your questions as an email, because we have the time extension. I need to go to get second speaking. So.
Okay, thank you.
Thank you.
Okay, thank you for listening.
Thanks for your nice presentation. İkinci konuşmacımızı davet etmek istiyorum. Rayna Hadim, Zeynep Dahi, Nazar Muhammed Halim tarafından yapılan diyabette devamlı egzersiz ve safran kullanımının insülin direnci ve glikozun hücre içine alınımına etkisini sunmak üzere konuşmacıyı davet ediyorum.
Merhabalar Sayın Hocam ve değerli arkadaşlarım. Ben Zeynep Dahi, Afganistan'dan katılıyorum. Öncelikle saygılar ve selamlarımı sunarım. Şimdi sunumu paylaşmak istiyorum. Hocam sunumu görebiliyor muyuz?
Henüz gelmedi.
Ustad İhsan Eksa devam edelim. Hocam geldi mi?
Şu an hala gelmedi bize.
افتادم زوم میخوایم پرزنتیشن شیر کنم نمیره شیر اسکرین گفتم
با شما هست هستین شما نمیتونید
میتونیم همه arkadaşlar. Hocam benim sunum paylaşmamda izin
Arkadaşlar,
verdiniz mi?
post yapar mısınız Zeynep Dahi?
Vermiş olmam lazım, bir dakika.
Zeynep Dahi host görünmüyor.
Tamam, kusura bakmayın hocam.
Tamam.
İki
Zeynep şimdi paylaş.
ilk yazara paylaşmışım da ben o yüzden.
Tamam sıkıntı yok, halloldu.
Geldi mi hocam?
Geldi, şimdi geldi.
Tamam. Ben hocalarımla beraber tip 2 diyabette devamlı egzersiz ve safran kullanımının insülin direnci ve glikozun hücre içine alınma etkisini ele aldık. Bu konuda çalışmak istiyoruz. Hazırladığımız sunumu sunmak istiyorum. Bizim konularımız giriş, egzersiz ve diyabet, safran ve diyabet, egzersiz ve safran ve diyabet. Yani diyabet üzerindeki etkileri, sonuç ve kaynaklar olacak. Şimdi diyabetten bahsedecek olursak günümüzde dünya çapında çok yaygın olan bir hastalıktır. Bu hastalık her 12 kişiden bir kişide bulunmaktadır. Ama bu hastalığı taşıyan insanlardan her 2'den biri de bu hastalığı fark etmeden taşımaktalar. Bu hastalık hani iyileşmiyor, ömür boyu devam eden bir hastalık ama zamanında fark edilerek tedavi edilmezse bu diğer hücrelerin ve organların hasar görmesine hatta engelli duruma gelmesine sebep olabiliyor. Şimdi diyabet kendisini biyolojik açıdan ya da tıp açısından açıklamak istersek şöyle anlatabiliriz. Yediğimiz, içtiğimiz yemeklerimiz ki karbohidrat, protein ve yağlardan oluşuyor. Bunlar vücutta enerjiye dönüşebilmek için önce küçük parçalara parçalanmaktadırlar ki en küçük parçası glukoz denir. Glukoz midenin arkasında yerleşen pankreasın sergilediği insülin yardımıyla hücrelere geçer ve hücrelerde enerjiye dönüşür. Ve aslında glukoz başta beyin olmak üzere tüm organlarımızın besin kaynağı olarak bilinmektedir. Şimdi eğer pankreas insülini üretemiyorsa ya üretilen insülin normal çalışamadığında ya hücre insüline karşı direnç gösterdiği zaman diyabet hastalıkları ortaya çıkar. Diyabet hastalıkları genelde 2 türe ayrılır. Tip 1 diyabet hastalığı insüline bağlıdır. Yani pankreas yeterli insülini üretemediği zaman diyabet bir hastalığı ortaya çıkar ve bu en çok çocuklarda ve orta yaş altındaki insanlarda bulunmaktadır. Tip 2 diyabet hastalığı ise diyabet hastalıklarının %90 ila 95'ini oluşturmaktadır ve bu en çok orta yaş üzerindeki insanlarda bulunmaktadır ve çok tehlikeli bir hastalıktır ki bu hücrelerin zarar gördüğü durumda insülini ememediği ya insülin yardımıyla glukozu emip enerjiye dönüştüremediği zaman ortaya çıkar. Ve eğer bu zamanında yani tedavi edilemediği durumunda tehlikeli durumu kendine alabilir. Peki diyabetin belirtileri nelerdir? Ağız kuruluğu ve çok su içme, sık idrara çıkma, kilo kaybı, açlık hissi, yorgunluk ve halsizlik ve bulanıklık görmede. Yani görmede bulanıklık yaşıyorlarsa. Şimdi diyabetin komplikasyonları. Hani dediğimiz gibi eğer diyabet zamanında teşhis edilerek tedavi edilmezse bu beyin hastalıklarını ortaya getirebilir, göz hasarı olabilir, kalp hastalıkları olabilir, kalıcı böbrek hastalıkları ya da böbrek hasarı ortaya gelebilir, nöropati ve diyabetik ayak. Yani ayaklar kesilmek zorunda kalabiliyor bazen ve nörolojik hastalıklara da yol açabiliyor ki ayak ağrıları falan ortaya gelebiliyor. Bunun tıbbi teşhisi de açlık plazma glukoz seviyesi eğer 7 milimol bölü litreden büyük ise ya çok ise glukoz plazma glukozu, günlük plazma glukozu 11,1 millimol bölü litreden yüksek olduğu zaman bu hastalıkların taşıyıcı olduğumuz ya da yaşadığımız söylenebilir. Ya diyabet tedavisi hani söylediğimiz gibi net bir tedavi yok bunu iyileştirecek. Sadece farmakolojik yani ilaçları kullanabiliriz. Hani kontrol altına alabiliriz. Böyle söyleyebilirim.
Söyledin ki şeyden.
Ve yaşam tarzında değişikliktir. Bu tıbbi yöntemlerin ya farmakolojik yeterli olmadığından dolayı alternatif tıp yöntemleri sunulmaktadır. Bunlardan bir tanesi, en önemlisi de egzersiz yapmaktır. Yani şeker hastalığı tamamen iyileşmediği için şeker hastalığı taşıyan insanlar bu hastalıklara alışmalı ve yaşam tarzında değişikliklere getirmek zorundalar. Yani normal olarak egzersiz yapmalılar ve diyet yapmalılar. Bunlar dikkat edilmesi gerekiyor ki biz egzersiz ve safranın diyabet kontrolü üzerindeki etkilerini şimdi anlatmak istiyorum. Egzersiz ve diyabet hani egzersiz diyabet yani tip 2 türünde önemli bir rol oynamaktadır. Bu konuda çok çalışmalar yapılmış ve yoğun egzersiz ve normal egzersiz bunlar hastalığı türüne ya yaşına göre ve hastalığın ilerlediği yönüne göre belirlenmelidir. Doktor tavsiyesiyle bu alınması gerekiyor. Ve egzersizin insülin ve glukoz üzerindeki etkisi kan şekeri kontrolüne yardımcı oluyor. Glikojen olarak depolanan kaslarda glikoz alımı için söylediğimiz gibi glikoz normal olarak hücrelere ulaşamadığı zaman ya da enerjiye dönüşemediği zaman bu hastalıklar ortaya gelir ve zarara sebep olur. Ve bunun gibi birçok yani hızlı geçeceğim çünkü zamanımız az kalıyor sanki. Egzersiz türleri de güvenli alıştırmalar öneriliyor. Bu da doktor tarafından hastaya yönelik egzersizler söyleniyor. Yani herkes kendi başına ben diyabet hastalığım var diye egzersiz yapamaz. Çünkü egzersizler biliyoruz türleri var. Ağır olanları var, hafif olanları var, uzun süreli, kısa süreli. Yani gün içinde kaç dakika almamız gerekiyor. Bunları doktorun tavsiyesiyle almamız gerekiyor. Ki aerobatik egzersizler var. En çok bu önerilmiş diyabet hastalarında esneklik egzersizi ve dayanıklık egzersizleri de kullanılabiliyor. Şimdi bir egzersiz FITT özet olarak açıklanmalı altta yazıyor, oradan okuyabilirsiniz. Bu yöntemde şeker hastaları haftada 4 ila 6 kez egzersiz yapması gerekiyor. Yoğunluğu da haftada kalp hızının 50 ila 60'ında yani yüzdelik ve 30 ila 40 dakika egzersiz yapabilir. Bunun tip olarak da güvenli egzersiz önerilmektedir ve sabah yapılması söylenmektedir. Yani sabah egzersiz yapınca daha faydalı olmaktadır. Şimdi çalışmanın bir özetini buraya ekledik. Bu çalışmada hani sıçanlar üzerinde yapılmış. Bu egzersiz yapıldığı zaman sıçanlarda diyabete karşı direncinin ya hücrenin insüline karşı direncinde faydalı olduğu ortaya çıkmış. Yani bu egzersiz insanlar da yapabilirse uygulayabilirse şeker hastalığının iyileşeceğinde öneriler var. Şimdi bir de yemeklerden bahsettik. Yemeklerde de hani şeker bizim almamız gerekiyor ama normal bir şekilde almamız gerekiyor. Çok fazla aldığımız zaman insülin üretimi çok fazla olur. Bu kere de kan şekeri yükselir ve kan şeker hastalığı da ortaya çıkmış olur. Ondan dolayı şeker hastalıkları çok az dozda, çok sık sık yemek tüketmeleri ya da ara yemek tüketmeleri gerekmektedir. Şimdi şurada bir tablomuz var. Bu tabloda Big Snack demiş. Yani eğer biz yemeği şeker bol miktarda olan yemekleri birden çok fazla tükettiğimiz zaman o zaman vücut ya da pankreas insülini birden hızlı üretmeye başlar. Hızlı üretmeye başladığında da şeker hızlıca emilir ve enerjiye dönüşür. Bu sırada enerji patlaması olur ama hemen enerji bittiği zaman da düşüşe, enerji kaybına sebep olur. Şimdi kırmızı çizgiyi görebiliyoruz. Birden yükseliyor ve birden direkt düşüyor. Ve bu insan hatta ölümcül olduğunu, yani insanların ölme sebep olduğu söylenmektedir. Ama eğer ara öğünlerimizi sık sık aralıklı kullandığımız zaman şu sarı çizgiyi görebiliyor isek enerjimizi kontrollü bir şekilde saklayabiliriz. Şimdi safranın diyabet üzerindeki etkisinden bahsetmek istersem safranın kendisi çok uzun. Hocam,
Son 5 dakikanız kaldığını hatırlatayım.
Tamam hocam. Safran çok eskilerden bilinen bir bitkidir. Bu bitki kaynaklara göre 155 tane bileşen içermektedir. Bu bileşenlerden 3 tanesi kurusin, pikikurusin ve safranaldır. Bunlar biyoaktivite göstermektedir ve bu da şeker hastalıkları ya diyabet hastalıklarının kontrolünde çok önemli rol oynamaktadır. Son 200 yıldan beri safran üzerinde daha çok çalışmalar yapılmış ve çalışmalar yapılmaya da devam etmektedir. Şimdi birkaç tane yapılan çalışma diyabet üzerindeki etkilerinden bahsetmek istiyorum. Bir çalışmamızda 8 hafta 54 hasta üzerinde yapılmış. Bu da günlük çay şeklinde bardakta 1 miligram olarak 3 öğün çay içtiği zaman insülin direncini yükseltmektedir. Ve diğer bir çalışmada da günlük 30 miligram zaferanı çay olarak kullanmışlar 12 hafta süreliğinde. Bunda da şeker hastalıklarında faydalı olduğu görülmüştür. Ve Şirali diğer bir çalışmada da diyabet hastalıklarında safranın kullanılması şeker kontrolünde ya da hastalığın kontrolünde önemli olduğu söylenmektedir. Ama bu çalışmaların hepsinde önerilen şeyler şu. Hastalıklara yakın olan dozu, yani hangi hastalar ne kadar dozda ve ne kadar sürede bu safranı kullanması gerekiyor. Bunun için çok az çalışmalar yapılmış ve klinik ya da deneysel çalışmaların daha çok yapılması önerilmektedir. Şimdi şurada da bir özet olarak bir tablomuz var. Safran ve içerikleri. Safran özütü var, kurusin, kurusitin ve safranal. Dediğimiz gibi bu 3 bileşen şeker hastalığı üzerinde faydalı etkileri vardır. Şimdi hepsini açıklayamayacağım zaman kısa olduğu için. Şimdi devamlı egzersiz ve safranın kullanımı, diyabet üzerindeki etkisi. Eğer aynı zamanda hem safran kullanırsak hem düzenli egzersiz yaparsak bu şekilde diyabeti daha hızlı bir şekilde kontrol edebileceğimizi ve hayatımız normal bir şekilde devam edebileceğimiz söylenmektedir. Ve aynı zaman ikisi yani hem egzersiz ve hem safran kullandığımız zaman hücrelerdeki insülin salınımı uyarılan deneylere göre aktifleşmiştir, glukoz alımı iyileşmiştir. Yani hücreler normal bir şekilde glukozu alıp enerjiye dönüştürebiliyor. Şimdi şurada gösterdiğimiz gibi normal glukoz kırmızı şekilde, high glukoz da siyah şekilde.
Son dakikanın içerisine girdiğimizde hatırlatayım ben.
Tamam. Şimdi hızlıca özet geçeceğim. Eğer ikisi de aynı zamanda kullandığımız zaman hem normal glukozu vücudumuz ya hücreler emip enerjiye dönüştürebiliyor, hem glukoz çok olduğu zaman onu kontrol altına alabiliyor ve o zaman direkt ben sonuca geçeyim. Sonuç olarak şunu söyleyebilirim. Diyabet hastalığı ciddiye almamız gerekiyor. Kendimizi muayene ettirerek farkına varmamız gerekiyor. Diyabet hastalığı taşıyor muyuz, taşımıyor muyuz? Eğer ihyanen taşıyor isek o zaman egzersizlerimiz normal olarak kullanmamız gerekiyor ve yemeklerimizde diyetlere dikkate almamız gerekiyor. Aksi takdirde bu sadece şeker hastalığı olarak kalmayıp diğer organlarımıza başta hani beyin önemli noktalardandır. Beyin, kalp ve hasarlıklara da yol açar ve birçok diğer hastalıklara da sebep olabilir. Ondan dolayı dikkate almamız gerekiyor diye söyleyebilirim. Şimdi önerilerde de hani daha çok deneylerin yapılması ve bu deneyleri bizim takip ederek günlük hayatımızda değerlendirmemiz gerekmektedir diyebilirim. Son olarak da çok teşekkür ederim. Dikkatiniz için sorular varsa alabilirim.
Evet, biz de teşekkür ederiz sunumunuz için. Sorusu olan katılımcımız varsa bir tane alabiliriz. Sanırım yok. O zaman üçüncü sunumumuza geçelim. Üçüncü çalışmada Sabina Nezire, Emine Kandemir, Nehir Özdemir Özgentürk tarafından yapılan Curcumin Effect on HAS2 Gene Expression on Senescent Fibroblasts sunumu yapmak üzere katılımcıyı davet edeyim.
One second. Hello, everyone. I am Sabina Nazir, a master's student in Yıldız Technical University. Today I will be talking to you about the curcumin effect on HAS2 gene expression on senescent fibroblasts. I will start. One second. The table of contents, I will be talking about aging, senescence, human skin, fibroblast cells, hyaluronic acid, free radicals, and antioxidants, and curcumin. Aging. Biologically speaking, aging can be defined as time-related progressive loss of physiological integrity resulting in damaged function and increased susceptibility to death. Lately, it has been seen an increase of human elderly population, and by the year of 2050, 16% of the human population will be over the age of 65. And that's why in the last decade, healthy aging and the studies and anti-aging fields have gained big importance. The hallmarks of aging, well, let's say that aging affects every part of the cell, from genomic instability to telomere attrition to epigenetic alteration, mitochondrial function, loss of proteostasis, deregulated nutrient sensing, stem cell exhaustion, cellular senescence, and altered intercellular communication. But still, there is no a particular death gene. There is not a single gene that is responsible for the death or our lifespan. Only 25% of our lifespan can be related with heredity, and the remaining 75% is related with stochastic events. For example, the lifestyle, the environment a person lives, etc. Senescence. Senescence is a hallmark of aging. Well, senescence means growing old. But in cell culture, we use the word senescence for the time when the cells reach the part when they don't proliferate anymore. So cells in cell culture, they keep remaining alive, but they don't proliferate. They reach the stop of their proliferation. The biomarkers of senescence, they include the cell cycle arrest, as I mentioned, the morphological transformation, the reactive oxygen species, DNA damage-induced senescence, etc. And one of the most important is the senescence-associated secretory phenotype, SES. This means the senescent cells secrete proteins, different proteins, which are able to cause inflammation in the body. And this inflammation can be related with aging and age-related diseases. But senescence is not only negative. The senescence takes part in different processes such as embryonic development, wound healing, organism aging, and tissue repair. So it has opposing effects. For example, it helps in tissue repair, but it can cause aging also. It can suppress the tumor, but it can promote it. So it depends in the condition of the cell and in the tissue where it appears. As I said, is the main hallmark of aging. All the hallmarks of aging that I mentioned above are related with senescence. And also senescence itself causes stem cell exhaustions, which means that a decreasement in our body, in our body's or tissue's ability to renew themselves, and chronic inflammation, which also directly affects aging and age-related diseases. And it has been proven by different studies that the elimination of senescent cells can cure various age-related diseases from, for example, type 1 diabetes. And a lot of more researches are being conducted to prove it more. Human skin is the largest organ in our body. It's a sensory organ, protects our body from various factors, prevents the moisture loss, produces the vitamin D, regulates the body temperature, and acts as an immune organ to discover infections. It consists of 3 layers: the epidermis, dermis, and hypodermis. And it's the most studied organ for aging because it's it's the clearest aging indicator. We can see it clearly for when the skin ages, for example, wrinkles. But also it indicates other age-related diseases such as neurodegenerative diseases or cardiovascular diseases. Fibroblast cells are found in the dermis layer of the skin, are the most important connective tissue cells, have really important roles such as stem cell maintenance, fibrosis repair, healing, and tissue remodeling. And they are really important for our studies because of their heterogeneity. For example, fibroblasts taken from different tissues react differently in cell culture and in our studies. So that's why it's really important to study different fibroblasts. And the reason why we chose the fibroblasts for our study is because they synthesize the structural matrix components such as collagen, elastic fibers, hyaluronic acid, and proteoglycans. And what we focus is the hyaluronic acid, hyaluronan. It belongs to the extracellular matrix. It's one of the most important molecules in skin moisture because it has the capacity to retain water. And it's, well, as I said, it's found more in dermis compared to epidermis of the skin. And because, well, as I mentioned before, because the dermofibroblasts provide the synthetic machinery for hyaluronic acid, they should be the target for pharmacologic attempts to enhance skin hydration. Has2 gene, well, it's one of the 3 genes that synthesizes the hyaluronan, but it's the most important one, and is responsible for the multipass transmembrane protein located in the plasma membrane. And as I said, it's responsible for the hyaluron deposition in the extracellular matrix. And it's that important that, well, mutation causing the Has2 disruption during development results in embryonic lethal. Free radicals and antioxidants. In chemistry, a free radical is a molecule that has 1 or more unpaired electrons, and these molecules are extremely active. And in biology, these molecules in cell biology are produced during the normal cell metabolism, and they can cause various damage to DNA, to carbohydrates, to lipids, and to proteins. And according to the free radical theory of aging, or the oxidative stress theory of aging, the accumulation of the oxidative damage of the cell macromolecules lead to the age-related functional losses. So, well, the free radicals are the free radical study and antioxidant study is really important for us to study the age-related diseases. There are various yeah, there are endogenous and exogenous processes that produce free radicals, and the same exists with antioxidants too. The antioxidant are substances that protect cells from the damage that is caused by free radicals, and the antioxidant and the free radical, when they're not in a balance, the oxidative stress is produced. Well, for aging, it's really important, as I said, the eccentric factors, the lifestyle. And according to data, the diet, especially the Mediterranean diet and Okinawa diet, are good antioxidant sources. And usually, like they studied the centenarians, people that live 100 years and more, and they saw that these people consume mostly this type of diets because they are a source of antioxidants. Curcumin is one of the sources of these antioxidants. A phenolic compound comes from Curcuma longa plant. It's one of the 3 bioactive curcuminoids of it, and it's found in a big percentage. And it has been used for more than 20,000 years in Asian medicine, fabric, dyeing, cosmetics, etc. And in the last years, it has gained a lot of attention because of its anti-aging, anti-cancer, antibiotic, and anti-inflammatory effects. And because of this, it has gained also a big, a global market, an increase in the global market size. Curcumin can affect several biological targets. It can affect the cell cycle proteins, it can affect enzymes, growth factors, transcription factors, cytokines, and inflammatory pathways. And that's why we found it important to use curcumin to address the gene of the HAS2 gene. And also it plays a role in epigenetic changes and microRNAs. And curcumin also affects different biological processes: proliferation, apoptosis, migration, inflammation, redox states, wound healing, and has a positive effect, as I said, on aging, and age-related diseases. But the bioavailability of curcumin is really low because in gastrointestinal tract, it stays for a small amount of time, and it's quickly absorbed. So that's why to increase this bioavailability, it's important from us scientists to use adjuvants, curcumin nanoparticles, or reformulate curcumin with different oils or metabolism inhibitors in order for the people to be able to take the needed dose of curcumin to get the needed.
Sorry, just you have 5 minutes left.
Okay, curcumin also has a hormetic effect, just like I mentioned senescence that has contradictory effects. Curcumin also, according to its dose, it has different effects. For example, if we take it on low concentration, it is a stimulant, but if we take it on high concentrations, it can be an inhibitor. And it has been shown that curcumin is not toxic to humans. It can be taken orally up to 8,000 milligrams per day for 3 months without any side effect. This is all I had to say. I wish everyone a long and healthy life, and thank you for listening. If there is any questions.
Thanks for your nice presentation. Is there any question for our speaker? Nobody has. Okay. Sıradaki çalışmamız da Ebru Büşra Tunçköy'de ve Emine Kemiklioğlu tarafından yapılan Detection of MRSA Bacteria Using Liquid Crystal Based Sensing Method. Çalışmayı sunmak üzere Ebru Tunçköy'deyi davet ediyorum.
Sesim geliyor mu hocam?
Geliyor.
Tamamdır. Başlıyorum. Şu an ekran geldi mi hocam?
Ekran geldi ama slide... şimdi slaytlarına da geldi. Tamam.
Good morning, everyone. We carried out the study that I will tell today to get dear instructor, Associate Professor Emine Kemiklioğlu. My presentation topic is detection of MRSA bacteria using liquid crystal-based sensing methods. Liquid crystals are state of matter that has properties between those of conventional liquid and those of solid crystals. They flow like liquid crystals are state of matter that has properties between those of conventional liquid and solid crystals. They flow like a liquid, but they have molecular alignment properties of the liquid crystals. Liquid crystals are divided into the two groups, thermotropic and pleiotropic. The thermotropic liquid crystal phase depends on the temperature of the substances. Pleiotropic liquid crystal phase depends on the concentration of the substances. Thermotropic liquid crystals are divided into the two groups, nematic, cholesteric, and symmetric. Thermotropic liquid crystals can show some of the properties of the both solid and liquid substances in the same temperature range. Liquid crystals have a rigid, long, and rod-like molecular structure due to the aromatic ring. In a nematic phase, molecules have a long-range orientation order with the molecular long axis aligned along a preferred direction. The preferred direction may vary throughout the environment and is called the director. The orientation of the director is represented by a unit vector. In the nematic phase, molecules show an orientation order as in nematic phase. The symmetric phases, which are found at lower temperatures than the nematic phase, form well-defined layers that can slide over one another. In a cholesteric phase, the substances in the cholesteric phases consist of layers with a nematic structure. The transition of the molecules between layers is possible. The change in orientation of these molecules, the molecules show a helical twist throughout the material. In a lyotropic liquid crystal, lyotropic liquid crystals generally consist of two or more components, one of which is a polar character. It is an amphiphilic molecule with two immiscible hydrophilic and hydrophobic pairs in the same molecule. Liquid crystals are used in many application areas, such as artificial organs, membrane, biosensors, and LC thermometers. The most important of these are the biosensors. Working principle of the biosensors. Biosensors consist of the two main parts, the sensing element and transducer. That which interacts with the analyte can be enzyme, microorganism, and nucleic acid. And as a result of the interaction between the biosensing element and analyte, physical response occurs. The transducer provides the transformation of the physical response into the measurable signal. Biosensors show variety according to the transducer and categorized as the electrochemical, optical, colorimetric, and piezoelectric. Liquid crystal biosensor is an example of the optical biosensor. In the working and measurement principle of the liquid crystals, liquid crystals molecules aligned vertically on the glass slice, the incident light passes through the LC layer, and therefore the optical image will be observed as the bright black pattern under the microscope. If the alignment of the LC molecule is tilted in the presence of the analyte, the incident light on the LC surface will see two light beams with a different propagation direction. Thus, LC optical image will be observed as a bright image. This study aims a new scientific method was developed to detect the presence of the methicillin-resistant Staphylococcus aureus bacteria, which propagate within the isotonic water and phosphate buffers alike by using the orientational responses of the liquid crystals. MRSA is known as the most common series-resistant strain in the hospital, and MRSA can easily spread to the hospital through the... Hocam şu an sesim geliyor mu?
Evet.
Tamam, internet bağlantısında sorun oldu. MRSA-related infections always cause serious antibiotic resistance illnesses. This bacterium can also survive in harsh environments, grow and produce virulent proteases, leading to staphylococcal food poisoning that causes serious gastrointestinal symptoms such as diarrhea and abdominal pain. These are the materials and instruments. Firstly, we prepare the solid and liquid medium preparation. In the solid medium, liquid agar was suspended in the distilled water and boiled. The medium was then sterilized by the autoclaving. In the liquid medium, tryptophan, sodium chloride, and yeast extract were added to the distilled water. After obtaining the homogeneous mixture, the medium was sterilized by autoclaving. Inoculation process, bacteria were inoculated on agar plates using a swab by streaking method and incubated. The bacteria were transferred from the solid medium to the test tube involving the liquid medium by using the loop, and the test tube was incubated. The bacteria culture was sterile diluted to obtain bacterial colony-forming units of the original stock. 0.9% sodium chloride dilution liquid was prepared to be used in the dilution process. Before the analysis, 4.5 milliliter sterile dilution liquids were put into the sterile tubes. 0.5 milliliter of liquid crystal was taken from the stock solution and transferred to the first tube. At the end of the transfer to the test tube, the total volume in the first tube became 5 microliter. At the same time, 10 times dilution was made. The same procedures were continued and the dilution was made up to 10 to the power negative 8, as seen in figure 12. The diluted samples were transferred onto the agar petri dish. The sample was spread homogeneously over the surface of the medium, and agar plates were incubated. Plates between the 15 and 300 colonies were prepared for the colony counting. And counting was performed on 2 plates that were inoculated from the same dilution. At average, we found the stock solution concentration 9.2 times 10 to the power 7 CFU per milliliter. PBS preparation process, powder PBS was mixed in the profiled water until the homogeneous. PBS sterilization was performed with the Schringer filter. Dilution procedures for PBS were performed in the same way. The stock solution was diluted to 10 to the power negative 8. We found that the stock solution concentration 7.1 times 10 to the power 8 CFU per milliliter. Preparation of the DMAP coated glass slides. Glass slides were sequentially washed in deionized water, IPA, isopropyl alcohol, and ethanol in an ultrasonic bath at room temperature. After the clinic processes, the slides were immersed in the aqueous DMAP solution. Then they were with the ionized water to remove the excess DMAP. The glass slides were dried and allowed to cool to the room temperature. Acidic molecules heated at the 45 centigrade degree was dropped onto the DMAP coated glass slides. Then MRSA solutions prepared with isotonic water and PBS dropped onto the liquid crystal. LC optical cells was fabricated by sandwiching two glass slides, DMAP coated glass slide and DMAP coated slides involving the bacteria. The changing of the LC orientation caused by bacteria binding was observed using the form and reflection spectra were determined under the spectrometer. Our methods, firstly, in the DMAP glass slides were coated with the DMAP alignment agent to enable to homotropic alignment of the LC molecules. And then LC molecules were assembled on the DMAP coated glass slides. The LC molecules were vertically aligned. When the bacteria binding to the DMAP plastic surface, the homotropic alignment was disturbed. This change of the LC molecules orientation was observed under the microscope. Optical texture LCs on the DMAP coated and uncoated glass slides were both examined to realize the effect of the DMAP coating. The optical texture of the LC was observed as a bright image in the figure A. In figure B, the optical images were dark because the LC molecules were induced to the homotropic orientation via the DMAP coating process. Detection of the MRSA bacteria. As shown in a figure 21A, LCs had a homotropic alignment on the DMAP coated surface in the absence of the MRSA bacteria, and the optical image of the LC molecules was uniformly dark. As the concentration of the bacteria increased from 0 to the 9.2 times 10 to the power 7 CFE per milliliter, increased brushed optical image were recorded as seen in figure A to the F. The low MRSA bacteria concentration did not induce the apparent orientational change of the LCs because the amount of the bacteria, MRSA bacteria binding was too low, as seen in B to the C. Due to the F demonstrated that there is an essential orientation transition in the LC molecules due to the increasing concentration of the MRSA bacteria. In the PBS, as the concentration of the MRSA bacteria increased from the 0 to 7.1 times 10 to the power 8 CFE per milliliter, increased bright optical image were obtained under the foam as shown in figure A to the F. At low concentration, the change in the LC orientation was not distinct because the amount of the MRSA bacteria binding events was low as seen in figure B to the C. Figure D to the
Bu arada
F,
3 dakikan kaldı.
Tamam hocam. Indicated that significant change in orientation transition were observed with the increasing concentration of the MRSA bacteria. Following the POM analysis, the reflection change caused by the LC molecular orientation change depending on the amount of the bound bacteria were determined with the spectrum meter. As shown in figure A, the reflection percentage in the presence of the 9.2 times 10 to the power 3 CFE per milliliter MRSA bacteria concentration was obtained as a 30.18%. When the MRSA bacteria concentration was raised to the 9.2 times 10 to the power 4 CFE per milliliter, the reflection value was obtained as a 35.15%. Reflectance values were obtained as a 45.61% and 57.09% for the 99.2 times 10 to the power 5 CFE milliliter MRSA bacteria concentration, and respectively the reflection values of the 63.17% was obtained at the highest MRSA concentration. In the PDX, the reflection values of the 33.91% at the lowest bacteria concentration. When the MRSA bacteria concentration was increased to the 7.1 times to the 10 to the power 5 CFE per milliliter, the reflection values was obtained was 44.44%. Reflectance values were obtained as a 50.05% and 56.97% for the increasing bacteria concentration, respectively. The reflection values of 60.70 was obtained at the highest MRSA concentration. Orientation change of the LC molecules led to the essential change in the sample reflected as seen A to the B. As all the results were examined, the change in the optical texture of the LCs and the change in the reflection values were consistent. In a conclusion, our new biosensing system has us show up a favorable, easy option to detect MRSA bacteria in a faster and efficient way. That brings me to the end of my presentation. Thank you for listening to me.
Teşekkür ediyoruz güzel sunumun için. Sorusu olan arkadaşımız var mı?
Hocam bir sorum var. Sorabilir miyim?
Tabii ki.
Şöyle şu İngilizce konuşayım da iyi. You have used LC liquid crystals for the detection of MRSA, but you used MRSA culture, a pure culture. If we have a mixed culture like MRSA and other bacteria, how we can use this liquid for the detection of just MRSA, or if we can use this liquid crystal for the detection of other bacteria. I just want to know if we can use this liquid culture as biosensor of other bacteria. Thank you.
Other bacteria can detect our systems.
Kullanıp kullanmadığını soruyor.
Kullanıp kullanmadım.
Kullanıp kullanmadığımızı soruyor. Evet, başka şeyleri kullanıp kullanmadığımızı soruyor.
Yok, kullanmadık.
In English.
Nothing. I didn't use another bacteria in this system. Only the MRSA bacteria.
Okay, thank you.
Ebru benim öğrencim olduğu için müdahale etmiş oldum. Bu arada onu da açıklayayım. Soruyu çevirme gereği duydum. Sıradaki çalışmamız da Muhammed Şampiyon Mukobu'yu, Nazlı Böke Sarıkahya, Ayşe Nalbantsoy, Murat Edibol tarafından yapılan Biosensors of Metallic Nanoparticles using Cephalaria Plant Extracts sunumu yapmak üzere konuşmacıyı davet ediyorum.
Good morning. Is the slide up here?
Yes.
Good morning, everyone. I am Muhammed Shafi from Comoros Island. Komor adalarından geldim. Ben Ege Üniversitesi'nde doktora öğrencisiyim. Biyomühendislik bölümünde. Benim sunumum İngilizce olarak sunum yapacağım. First, I would like to thank for all the organizer of this program. And my title, my work, it will be titled by the Biosynthesis of Metallic Nanoparticle using Cephalaria Plant Extract with the biopharmaceutical process activities. The contents, terminology, abbreviation, and all these things, I'm not going to just terminology. We have to use about nanoparticles. Nanoparticles, it's a small particle from the size of 1 nanometer to 100 nanometer. And I'm going to use to speak about green chemistry, which we focused for the use of some things which cannot be harmful to the body or for the living organism. And as biological activities also, I think everyone knows about that. Some abbreviation has been used. In my introduction, I'd like to clarify that nanotechnology, we have nano and technology, is two words which is combined together. At the same time, in nanoparticle synthesis, it's under two main approaches, which is top to down, which is physical methods, high consumption of energy, and we have bottom to up, which is like chemical and biological methods. And these biological methods are eco-friendly properties, and it's less hazardous, and it's also low cost. In my studies, we have studied about a Cephalaria plant known by Cephalaria chihachewi, originated from the name Chihachev, which is the first publisher. And this plant, it's endemic from Turkey, where it's the red places where it's found. It's in Antalya. And the objective of my work, it's like we have to take the Cephalaria plant, do extraction, and from the extraction, we have to use, we have used 4 different organic solvents. And we have, from the extracts, we have taken the butanol extract, we have done some isolation of secondary metabolites, especially saponin, flavon, and iridoids, and some methyl glycoside. At the same time, we have done in both in extracts and all the isolated secondary metabolite. We have produced nanoparticles in which we will have to go and check the biological activities of them. Coming to the first materials that we have the extraction process, we have taken the Cephalaria chachewi, dried it with methanol. After that, we have taken the butanol extract, and we have done a separation from butanol and water extract, because we know like some components can be dissolved in butanol, and that's what we wanted, because that saponin saponin compound are mostly soluble in butanol and other water extracts. From that, we have done, and we have got like 8 fractions from the RP vacuum liquid chromatography. From this one, we have taken the 4th and the 5th fraction. From that, we have done some MPLC, which is the medium pressure liquid chromatography with silica as the mobile phase, as the stationary phase, in which we have got like the F1, it's the fraction 2, fraction 4, and fraction 6. From this, we have like isolated more than, we have isolated like 15 pure compounds, in which all these compounds, I didn't use it, but just I have selected 4 of them. And I have, for the first one, I have the extract, which will be combined butanol extract, water extract, methanol extract, and a mixture of saponin extracts, in which I have taken the CTC8, it's a saponin, this is another one, CTC9, it's an iridoid, CTC12, it's a methyl glycoside, and the CTC13, it's a flavonoid, in which I have done the green synthesis of metallic nanoparticle, which I have used silver nitrate and zinc sulfate. At the same time, I have done the incubation, and after centrifugation, we have selected the nanoparticles. Okay, sorry. Okay, after doing the nanoparticle production, we have characterized. We have 2 characterization: pure compound characterization, in which we have done NMR spectroscopy, and high resolution mass spectroscopy. We have done FTIR for the novel compounds, and for basic hydrolysis and sugar analysis. In order to characterize the sugar, we have done GCMS. For the second section, we have used the green nanoparticle synthesized particles, in which we have characterized them by UV and DLS at a dynamic littering scattering, and same with FTIR. Coming to the result, because I don't want to take more time, the result we have, this is the first compound, which is a newly described compound. It's not found in the literature right now, and we have got the chance to be the one who discovered this compound, or to describe this compound. We have named as CHOCID-A. The second one, it is CHOCID-B. It is also a new compound. From the 15 compounds we have isolated, we have got 2 new compounds, which I have already spoken about. And for the others one, it's already known. It's the compound 3, and it's the compound 4, saponin. It's also a saponin. And also this one it's a saponin. It's a saponin, saponin. And this one, it's loganoic acid. It's a different one. It's not a saponin. We have also get the flavonoids, this one, and we have also a methyl glycoside. It is for the phytochemical properties, because I have done my project in 2 different departments. One of them is the phytochemical, which I have already showed you all the results, and the other one. Okay, this is the characterization of the new compound. All of them we have to do NMR, proton and carbon NMR. This is how we can characterize that. We have to check the peaks, and after that we can go for further processes just to know about the exact compound we have already done. It is the proton NMR. Coming to the biosynthesis of metallic nanoparticles, especially here, I have already done with extract, but I just wanted to show you what I have done with the pure compound. In the pure compound, I have saponin and iridoid and methyl glycoside and the flavonoid. This is for the silver nanoparticles. At the other side, the right side, we have the zinc nanoparticles, the same compound we have used. And we have known like the change of the color of the silver here. It's an indication of like we have nanoparticle production, because we didn't want to use any harmful or any physical thing. Just we have used the co-precipitation method for the nanoparticle production, and it is the result. I come into the characterization for the UV. For the UV extraction, we have this one. Most of them, they have shown like there is a nanoparticle production, because the maximum peak has been selected from the range of 380 to 450 nanometers. Coming to the DLS, we have I'm going to give you one by one. This is for the silver nanoparticles. And this is like a homogeneity of nanoparticles. Coming to the second one, the iridoid, and this is the methyl glycoside. Also, this is the flavonoid, a silver nanoparticle. Coming to the zinc nanoparticles, this is the saponin, which is like 154. The iridoid, which is a little bit high, 405 nanometer. Methyl glycoside with 319 nanometers, and for the flavonoid is 272 nanometers. Oh, same for the same. Okay, the DLS, the difference between this one and that, the same. The DLS, it can give like an average range, but this one we can know the shape and the size of the nanoparticles. In which I have done this one. Just I want to know about the age, the silver nanitrate. It's then going to. It is given. Affection of the nanoparticle production, but while coming to the end, the same, we don't have any particles here. While the saponin, it's given like that, like from 30 and 80, iridoid, methyl glycoside, flavonoid. For the zinc nanoparticles, also we have the saponin, only the zinc sulfate particles, which is not given a proper particles. At the same time, we want to compare about the saponin, iridoid, methyl glycoside, and the flavonoid zinc nanoparticles. Coming to the fifth, it is for the extracts. I don't want to take time about that. But the most important thing I wanted to show, it's the biological activity, which is the most important for all our works. While doing anything, we have to know what is going to be the effect of these products. I have done the cytotoxic activity, in which we have selected 4 types of human cells. One of them it's the lung non-cancerous human cells, CCD34LU, and the lung human cancerous cells, and the prostate. Also, we have the breast. It's the last one. Coming to the result, we have like compared to we have used the control as the doxorubicin. Compared to the doxorubicin, most of the saponin, most of the compound silver nanoparticle products as given good. Not a significant, but it's a good compared to the doxorubicin. But we have known like maybe it's been affected by the silver nitrate. If we see down here, we have 13.51. Coming to this one, it was a non-cancerous cells, the lung, but this one it's a cancerous human lung cancers. And here we have these activities. It's a moderate activity compared to the doxorubicin. Coming to the prostate, here we have a significant result, because when we compare the saponin silver and the iridoid silver and the methyl glycoside silver nanoparticle compared to the doxorubicin as a positive at a control, we find like it's low, which is better. And we know here maybe it's been affected by the silver nitrate nanoparticle, silver nitrate, because it's given 2.35, and it's a good result for that. Coming to the breast human cells cancers, also for the saponin silver, it's given a good result, which is low than the doxorubicin. Coming to the other one, I have done the antioxidant activity. Also, the antioxidant activity compared to the control, because the control is the ascorbic acid, we have like here in this chart, we have luteolin, like the flavonoid. It has given, it is a flavonoid, because I have done the nanoparticles with silver, nanoparticle zinc, and the pure compound which I have selected, and found like the zinc nanoparticle compared to the silver nanoparticle are a little bit more, and also the pure compound also it's given a good activities. Coming to the anti-inflammatory, in which I have used the inhibition of albumin denaturation, also compared to the control, which is the aspirin, here the acetylacic acid, we know that we have get like the silver nanoparticle produced, it's given a good result, a significant result according to the anti-inflammatory activities. Here also I have used an immunomodulatory activity for the newly described compound named by chihachosoid A and B, in which we have get like some stimulation to the EL1 beta cells. Coming to the summary of my work, because I don't want to take more time, the Cephalaria Plant, we have done 2,4 extract. We have done from the 4 extract, we have done a part of zinc nanoparticle and silver nanoparticle. The cytotoxicity, it's moderate, especially with water, saponin, and methanol extract. Cytotoxicity activity of the silver nanoparticle is moderate, especially with the water and methanol extracts. From the 4 extract, we have isolated 15 compounds, in which we have 2 new compounds, this one A and B, chihachosoid A and chihachosoid B. And for these 4 known, I have taken 1 saponin, 1 iridoid, 1 methyl glycoside, and 1 flavonoid. I have done zinc nanoparticle and silver nanoparticle. The zinc nanoparticle of the pure compound, it's given a moderate antioxidant and a low anti-inflammatory, while the silver nanoparticle of the compound, it's given a significant cytotoxicity, low antioxidant activity, and a high anti-inflammatory activity. Coming to the pure compound itself, we have a high antioxidant activity and a high anti-inflammatory activity. Coming to the novel compound, we have done the immunomodulatory activity, in which we have got the chance to do our first publication. We have already sent it, and we have sent, and I hope it will be accepted within 5 days. It will be coming to us. And it is the acknowledgement. Let me to thank, especially for my 2 supervisors, Professor Dr. Murat Elibol and Associate Professor Dr. Nazlı Bökesarka here, who sent symbol because they have the second one, they have provided us the plants. Ayşe Nabaltsoy, because we have done all the activities with them, and the Gebze TÜBİTAK Marmara Research Center, in which we have done most of our NMR. At the same time, we have done with the bioengineering department of the Ege University, we have done our DLS experiment. Let me thank the BAP project of the Ege University to find all my project. At the same time, to thank the ETB scholarship, because of them, and because of Allah and them, I'm here and I'm trying to manage with their scholarship. And I'd like to take this opportunity to thank the organization of this committee at the 5th International Student Science Congress, and to all my laboratory teams, co-workers, especially my sister Gaye Sumer, who is especially standing with me for everything. References are there. Thank you very much. And for any question, this is my email and my number, please. Thank you.
Thank you for your nice presentation. Is there any question for our speaker?
If we have time, I have Very short
Yes.
question.
Me too also,
Yes.
I have some question about that, about the
Thank you.
presentation.
Then let Muhammad ask the question.
Okay, thank you,
Yeah.
sir, because it's so
Welcome.
interesting. Thank you, Mohammed, for your nice presentation.
Thank you.
My first question is about incubation. You use 80 degree for incubation. Is the
Yeah.
temperature affect the incubation?
Can I answer directly?
Yeah, it should.
Okay, for the incubation, mostly this one it's only for the zinc, but for the Ag, for the silver, most of them, because I have done it many times, and I wanted to compare about the yields. For the 80%, because already we have nanoparticle, it's not affecting, because when coming to the SAM, we didn't get much difference. I have done with room temperature. At the same time, I have done with 80 for the zinc, because the zinc it's a little bit hard, and this is what we didn't get any modification. I was thinking, as you like, maybe it will be affected the morphology and the shape of the structure, but we couldn't get any modification according to that.
Thank you. My second question is about the particle size of your dry sample. What is the exact particle size? And also the particle size affect the process?
Yeah, normally we need, as we know, we are working in nanomaterials, nanoparticles. We need to be in the range of that one. But okay, the size, because there is two affection to get the aggregation of some nanoparticles when it's given to be weighted. So the size, some of them, because I have a huge of number of nanoparticles. So for the silver nanoparticles, there is a range. Some of them, as I have shown, I don't know if I can show here. Some of them we have like from 30 nanometers to 125 nanometer. Some of them we can have like 80 nanometer. Some of them we have 400 nanometers. So there is no a special range, because I have used different type of compounds with different type of with two different type of metals. That's why we don't have a special, but we have a range from, like for saponin, we have from 30 to 125 nanometers and so on.
Thank you so much, Muhammed.
Sanırım Mehmet Çevik Hoca'nın internetinde bir problem çıktı. Sistem dışı kaldı. I have the quick question for you.
Thank you.
Could you go back to the slide number 27 or 28? Let me see it first.
27?
Should be 27. I am not sure. Maybe 28. Next one. Okay. Here, these are the SEM images, right?
Yeah.
My question is, what was your motivation using the zinc sulfate 7H2O? And the other question, how did you remove the water from the system? Because you already talked about you didn't observe anything in the SEM image.
I didn't get the second question.
How did you remove the water from your system?
Normal. Okay, for the first one, I used this zinc sulfate because I wanted to do zinc nanoparticle, and I didn't have another type of zinc zinc salt in my laboratory. That's why I have used that. And also regarding to the literature, some of them they have been used, and that's why I have used that. This is the first one. The second one, because normally when I want to do this one, I have put in the oven at 80%. After precipitation, after centrifugation of the nanoparticle, I have collected the pellets. Then I have put it in the oven under 80%. Then after that, I think it was dried, and I have sent it to the same analysis.
Did you use the vacuum or not?
No, I used only in the oven inside, like a vacuum, but I didn't use the oxygen vacuum. I used for only when I was preparing the antioxidant activities only, but while doing this nanoparticle, I didn't use.
Okay, thank you.
Welcome, thank you very much. And Mehmet Çevik Hocam, please.
I think he is not here, maybe because of the
sorry.
internet problem.
Okay.
Okay, we need to move the next talk. So the next
Thank
talk.
you very much.
Thanks for your nice presentation again. So sıradaki konuşma da Ceren Özdemir ve Sema Erişen tarafından yapılmış olan The Effect of Plant Growth Regulators on Callus Induction in Salvia Cephalaria. Çalışmayı sunmak üzere konuşmacıyı davet ediyorum.
Hello, everybody. I'm Ceren Özdemir. I'm a senior licensed student in Yıldız Technical University Department of Molecular Biology and Genetics. And my title for the research is The Effect of the Plant Growth Regulators on Callus Induction in Salvia Cephalaria, as known as Cephalaria. Here we have our content. At first, I'm going to talk about introduction, and second, I'm going to explain our materials and methods that you are seeing right now. At the third part, we're going to talk about our results. And the fourth part, we're going to talk about our conclusion. At the introduction, Salvia cephalaria, as known as Cephalaria, is an annual medicinal plant that has an economic importance due to its secondary metabolite or essential oil profile. It grows naturally in the Mediterranean basin, especially on Turkey. It's grown in Europe and North America due to its economic importance. And when we want to talk about essential oils of the plants, on the above ground parts, we see flavonoids, monoterpenoids, and sesquiterpenoids. At the roots, we see diterpenoids. And these secondary metabolites has many properties, like they are antioxidant, antibacterial, anti-inflammatory, and many more that I can't count. And due to these properties, they are widely used in perfumery, food, and pharmaceutical industry. And while obtaining these secondary metabolites from medicinal plants under natural conditions, many difficulties can be encountered, like climatic conditions can be harsh, these plants can be endemic, or time needed for harvesting can be so long. So biotechnological methods, especially in this research, plant and cell tissue cultures are seen as an alternative way in the production of secondary metabolites to avoid these type of problems. Now, if we want to talk about our particular aim in this project or research, we want to create a new protocol with some plant growth regulator combinations and concentrations, and we want to optimize that for creating callus cultures in Cephalaria. What is callus? Callus is an irregularly clustered cell masses that has higher totopotency. With this particular sentence, I want to explain why we mainly focus on the callus culture, because it's easy to convert to the other cultures. As I said, they have higher totopotency, so we can start organogenesis or embryogenesis easily with the callus cultures, and we can produce some secondary metabolites better in callus culture due to their structures in some plants due to some researches. Now, up to the material methods. Now you are seeing the sterilization part of this plant. We start from seeds. We used 15% bleach at first for 5 minutes with the help of magnetic stirrer, and we used sterile distillated water for rinsing it off for 5 minutes, 2 times, if needed 3 times. Sterilization is important because contamination is a big barrier for this type of researches, and it takes long time to optimizing that part. After that, for germination, we put our seeds into murashige and cook medium supplemented with 3% sucrose and 0.7% plant agar, and we waited for 4 to 6 weeks to grow up. After that, you are seeing the media contents used in the study. We have dicamba-enoxin, metatopolin, and tidiazerone, 2 cytokinins. with or without 0.5 milligram per liter kinetin. And we used these particular concentrations in all of our experiments, 1, 2, and 4 milligram per liter. These plant growth regulators used with, again, Morschke and Sickle medium, supplemented with 3% sucrose, 0.7% plant agar, and 100 milligram per liter ascorbic acid. Why we used ascorbic acid in these ones? Because this type of medicinal plants are more likely to oxidize prone, and ascorbic acid is a great antioxidant. We used in this particular concentration, and that worked the best. And we adjusted the pH to 5.8, and media was autoclaved at 121 degrees for 20 minutes. Now, obtaining in vitro callus cultures, we created our cultures in 10x plants. We created with leaf X plants. We cut it to 0.5 centimeter wide square pieces. We put it into our petri dishes again in 10x plants. We waited to obtain callus cultures 4 to 6 weeks. After that, the cultures were evaluated in the terms of callus formation percentage, weights, and morphological characteristic of the calluses. We created our statistical analysis in bar charts. We set up our cultures in 4 replications, and again, as I said, 10x plants. And we created bar charts for these variables. Now, here we are seeing our morphological results in pictures. Here we have on the left 1 milligram per liter dicamba, and on the right 4 milligram per liter dicamba. In 1 milligram per liter dicamba, we can see the brown spots, the dead spots actually. We will count as actually alive because of these parts, these green parts, but in single X plants, viability rate is low due to these brown spots, and callus induction is low on a single X plant, again, only in this part, but in 4 milligram per liter dicamba, we can see callus induction all over in the single X plant, and viability rate is high. Green parts are actually seeable, and this has a better health actually. Other results that we gain. Here we have 1 milligram per liter T-deoxyrone and 2 milligram per liter metatopolin combined with 0.5 milligram per liter kinetin. Viability rate is zero, as you can see, and we have no callus induction in this one because we combined 2 cytokines together. That was actually, we thought about that, and we got the result like that. And after that, 1 milligram per liter T-deoxyrone, we saw some callus induction. They are good, but not good as 4 milligram per liter dicamba, and not all over the leaf, as you can see, like 4 milligram per liter dicamba, and viability rate is lower than the 4 milligram per liter dicamba. You can see again brown or dead spots in the leaf X plants. Here's an up-close look of the callus in 4 milligram per liter dicamba. Especially this callus is alive, has some green spots, and due to when we look up its texture, it has more watery texture, softer texture, is easy to work with. It built up strongly, but not strictly. Again, this makes it easy to work with and start up other cultures, especially cell suspension cultures. And as I said, production is all over the leaf, so this is more good. This is better. And here's another callus in 1 milligram per liter T-deoxyrone up close. This has more snow-like texture, and this built up actually more tightly, more strictly, but not strongly. It breaks apart so easily. And at the same time, it's not all around the leaf. For the single X plant, production is not good as the 4 milligram per liter dicamba, and we can see some that part, so viability rate is low in T-deoxyrone. And viability rates in percentage in the bar chart. We can see all of the dicamba trials has a rate of nearly 100. So this is the best trial in all of them, but metatopolin and T-deoxyrone doesn't have the greatest. And when we look up to the, especially on the concentration, when TD-01 concentration is increased, it decreases the viability. But metatopolin doesn't have the same results, it doesn't have the better results. When we look up to the callus induction, dicamba has, again, a rate of 100 nearly, but when we look up to the metatopolin and TD-01, especially mixed up with 0.5 kinetin, is up to the 0, but when we look up it's alone, again, we can see callus induction decreased when we increase the concentration of TD-01, but it's not the same in metatopolin. When we increase the concentration, it increased the callus induction too. Now you are seeing the callus weights of dicamba trials. Why I took dicamba trials? Because, as I said, they have higher callus induction, healthier callus induction. So I want to took the callus weight of them. And at the same time, production in single explant is all over the leaf. So that would give us the true results. When we look up to the callus weights, for dicamba, 4 milligram per liter dicamba has the best result of all of them with 2.8 grams in total callus weight. As a conclusion, in the study, we worked with dicamba, TD-01, and metatopolin for callus induction, and this is the first in literature. As I said, we optimized the concentrations of that too. And this is actually preliminary student for vegetative production studies, embryogenesis, for embryogenesis and organogenesis studies for Salvia Cephalaria. And as I said, it will contribute to complete lack of effect of different plant growth regulators in the literature on callus formation in Salvia Cephalaria. And we will work on some molecular researchers after that research. Thank you for listening. I would like to thank my supervisor, Semih Erşen, and all of the organizers of this Congress.
Thanks for your nice presentation. And is there any question for the speaker?
Yes. Yes, I have a question, sir.
Okay, what's your question?
Okay, thank you, sir. Sure. Thank you for your good presentation. Can you go back to your slide 6?
6. Okay. That was that?
Yeah.
Okay.
So, as I see from your sterilization, you use temperature or not? Because you are putting...
No, it was not that temperature dependent. I didn't use a particular temperature, but I actually didn't use too hot water because it will kill off the seed basically. But I didn't use a particular temperature for that.
Okay, thank you. And my second question, you said about callus culture is different from the others. The others, what are the difference between the others? Because I'm not in the field, so I'm curious about the culture. So can you give me a summary about the others culture and the difference? Just so.
Okay, I can basically say that callus culture is a starter culture of all of the cultures, because as I said in the past, it's it has a higher total potency, so you can create any plant, a plant embryo or an organ of the plant from calluses. They are irregular cell masses, but you can create an embryo or a plant organ from other explants, not directly on the calluses.
Thank you so much.
You're welcome.
So is there any other question? Burada 7. oturumumuzun sonuna gelmiş oluyoruz bu konuşmayla birlikte. Tüm katılımcılarımıza teşekkür ediyorum. güzel sunumları
Hocam,
için.
Kapatmadan bir arkadaşlar kamera açarsa hem toplu fotoğraf alalım. Size de ben teşekkür etmek istiyorum tekrar değerli katkılarınız için.
Ben de sizlere teşekkür ediyorum hocam böyle güzel bir organizasyon düzenlediğiniz için.
Arkadaşlar müsait olanlar kameralarını açarsa sevinirim.
Mehmet hocam bana soru sormak istediniz ya daha önce.
Onu
Acaba?
sorarım ben sana.
Tamam hocam.
Vakit ilerledi, meşgul etmeyelim. 15 dakika.
Tamam
gibi.
hocam.
Evet. Faruk hocam çekeyim mi? Tamam, Faruk Hoca gitti. Teşekkür ederim arkadaşlar.
Teşekkür ederiz hocam. Çok sağ olun.
İyi günler herkese.
İyi günler.
Ben oturumu kapatıyorum hocam. Tekrar açarım bir 10 dakika sonra.
Tamam. Hadi görüşürüz bakalım.
Görüşmek üzere.
Ahmet tebrikler.